Hello everybody, hopefully you're doing well. In this video, we're going to continue with section 5, factoring polynomials. We are still in the same chapter. It's a prerequisite factor that where we uh, go over some fundamental concept of algebra. In these sections, we're going to factor out the greatest common factor of polynomials. We're going to factor by grouping. It's a great technique. A factor trinomials, factor the difference of a square, perfect square trinomials, or factor the sum or difference of two cubes, and also use a general strategy for factoring polynomials. We can also factor algebraic expressions containing fractional and negative exponent. Without further ado, let's see what it is exactly. All right. So you know that you can distribute. I think definitely we go over these type of techniques. For examples, if we have 5 x times 2x plus 3, if they ask us to distribute these expressions, monomials with binomials, remember what we did? We multiply the expression, the terms outside of the parenthesis with each term inside of the parenthesis. So we do 5x times 2x give us 10x squared. Um, and we do also 5x times 3 give us 15x. You know, in some situation, instead of asking us to distribute, like we did in the previous section, remember in the previous sections, what we do is we have polynomials. What we could do with the polynomials, we could add them, subtract, multiply, and divide, but also we could distribute, like combine like terms. So, but in some situation, they might give you these expressions like 10x squared, the same thing, and ask you to reverse the process. All right. If you want to reverse the process, you need to identify common factors between these two terms, the 10x squared and the 15x squared. First of all, let's look at the coefficients. You said, what factors common to 10 and 15? Well, 10 is 2 times 5, 15 is 3 times 5. So because both of them has a 5, because for us, we can write this one like 5 times 2, and we can write this one 5 times 3. So we know 5 would be a factor, but inside of the parentheses, there would be a 2 left for the constant, and there would be a 3 left. Now, let's go with the um, variables. We see we have x squared and x. So that means we have two x's in this one, and we have only one x because there is only one x common to both. Then we know we're going to put that x outside of the parentheses also. Now, what we have left, we have x left for the first term and no x for the second term. And we keep the sign of the middle. So we call this process factoring. I know we go very quick. So factoring is factoring a polynomials expressed as the sum of monomials means finding an equivalent expression that is a product. Okay, so for us, we will our goal here. We will be factoring this set over this set of integers, meaning that the coefficient in the factors are integers. All right. So that's what we said. The goal in factoring a polynomials is to use one or more factoring techniques until each of the polynomials factors, except possibly for a monomial factor, is prime or irreducible. So what we mean by that, polynomial cannot be factored using integers coefficient are called irreducible over the integers, or they are prime. Okay, so what we're gonna do in these sections, the poly, the, you know, the polynomials, if you have them, we must factor them completely. There is no common factor. When you look at these two terms, there is no common factor remaining between these two terms. So that's why we said, okay, now we are certain we factor this polynomial completely. Now, in factoring, in any factoring problem, the first step is to look for the greatest common factor, as the abbreviation is GCF. We rarely said greatest common factor. We only say, oh, the GCF, find the GCF. The GCF is an expression of the highest degree that divides each term of the polynomial. So we need to remember that it's divide each term of the polynomial. So the distributive property in the reverse direction, you can do that also after you factor. You can distribute also. Now, if we just take a very quick look on an examples, let's say for we have 3x cube plus 9x square. Now, what we need to verify here, first determine the greatest common factor between these two. I see in the first expressions, I have 3. I have x, 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 that's 3x. Now, 9, what are the factors? 3 times x times x. Now, what's common to these two terms? You see 3 common, x common, x common. Now we can put outside these three. So we have 3x squared. 3x, so it's 3x squared. We can put it out, pull it outside. And then what we have left from the first term is x plus, that was a plus here, sorry. So plus, we have a 3 left. And that's it. That's the greatest common factor. So between x and 3, there is no more common factor. So we need to make sure that we take the highest common factor. Let's see an examples here very quick. If you look at these two terms, what is the common factor? Well, actually, you know 2 times 5 is 10. 2 times 2 is 4. So we know 2 would be outside. You see in this one, there is an x squared, there is an x squared here. So then you take the x squared, right? So you have 5x minus 2. There is a minus 2 here, right? Okay? If you're okay with that, so we do 2x squared times 5x minus 2. In this one, look, I'm gonna consider the whole thing here. I'm gonna call it A. Because this one also is the same expressions, I'm gonna call it A. Suppose for me, suppose you have 2x A plus 3a. Look at these two terms. What is the common factor between this and this? Yes, that's A. So A times, from the first terms, we have 2x left. From the second one, we have 3 left. Now, what is A again? A is x minus 7, parentheses. So we factor the greatest common factor. The greatest common factor between these two terms is x minus 7. Sometimes some of you might even try to distribute to x and for the first parenthesis and distribute 3 from the second. You're going to make it too complicated. But as long as you understand x minus 7 is a common factor, you can pull it out. But don't forget the parentheses, because if you only put this one, that's different. It's only negative 7 times the second parenthesis. So you need to make sure you put the parentheses so it could be a factor like that one, okay? If you don't have any questions about this one, how about we talk about grouping? Because grouping is a beautiful technique when you do factoring by grouping, because some polynomials have only one greatest common factor of 1. However, okay, however, by a suitable grouping of the terms, it still may be possible to factor. So this process called factoring by grouping. So when we said factoring by grouping, for example, so let's suppose you have x cubed plus 4x squared plus 3x plus 12. If I have something like that, all I need to do in this case is to combine two terms. I need to combine two because take any two terms that you feel like that has a common factor. What I'm gonna do, I'm gonna put these two together and these two together. So meaning I'm going to do x cubed plus 4x squared plus 3x plus 12. The only thing I do here is put a parenthesis. You see, I don't change any sign. Now, from these two terms, I need to identify the common factor. What's common factor between x cubed and 4x squared? Yes, x squared. So if you take x squared, then you have left only x plus 4. Now, look at the second one. What's common factor between 3x and 12? Yeah, 3 times 4 is 12. So 3 is the only common factor. So we have x plus 4 left. Now, if you remember in the previous examples, x minus 7 was a common factor. Now look at this one. You have x plus 4 and x plus 4 as a common factor. So we can pull it outside. X plus 4 as a common factor. From the first parenthesis, we have only x squared left. And from the second one, we have 3. And that would be our final answer. So we factor by grouping. So far, this is the most important section or chapters in algebra because factoring would be used in a variety and, well, I would say all math courses because factoring is what you use in your daily life also. You don't pay attention to it, but the common factors, you identify that all the time, all right, in your real life. Now, let's see through some very quick examples. We can combine any two, okay? If we look at this one right here, the only combinations I cannot do in A is x cubed minus 10. I cannot do x cubed minus 10 because x cubed minus 10 has no common factor. But if I want, I can put together x cubed plus 5x squared together, and I can put negative 2x minus 10 together. Why I do that is because both of them has a common factor. Look at the first terms. X squared is the common factor. If I pull out x squared, I have x plus 5 left. Now look at the second one, because you must have the same factors for both terms. I need to have a x plus 5 for the second one as well. If I only factor 2, then inside of the parentheses, I'm going to have negative x minus 5. And I don't want that. So what I would do is factor negative 2. So plus minus 2, if you want to see that, the plus outside and put in negative, plus times minus, give you minus. I pull minus 2. So x plus 5. Because I must have the same one in the grouping technique. So we have x plus 5 and we have x squared minus 2 left. You can combine any two. In this case, I took x cubed plus 5x squared together, but if you wanted, you could take x cubed minus 2x and you take 5x squared minus 10. It will give you exactly the same thing, right? You could combine any two. Now, let's see. I'm going to try to change the combinations. In the second one, I could put 3x squared, x cubed, minus 6x, okay, if I want. And I could put negative 2x squared plus 4. Remember, I could do also 3x cubed minus 2x squared plus negative 6x plus 4. I could do that as well. Now, what is the common factor for the first one? Yes, obviously, is 3x. Now, 3x, I have x squared minus 2. The common factor from the second one, remember I need a negative between x squared and 2. So I'm going to factor only negative 2. So if I factor negative 2, I'm going to have a positive x squared minus 2. It's a minus because remember I factor negative. So you see I have x squared minus 2, x squared minus 2. In this case, it's going to be x squared minus 2 as my common factor times from the first parenthesis I have 3x left. From the second parenthesis I have 2, negative 2, okay? And that would be it. That would be it. All right. So that's helped us a lot to make decisions about what techniques we're gonna use for grouping. But remember, you can always check your factorization by using FOIL methods. I mean, you just will multiply, because the fact when the factorization is correct, if you redistribute doing FOILs, you should find the same original algebraic expressions you have at the same original polynomials. Okay, so as you see, 4 terms is polynomials, 3 terms is trinomials, 2 terms is binomials, 1 term is monomials. We talked about it before. But how to factor? I think factor 4 terms is very easy. But when we have to factor 3 terms that we call a trinomials, it might be different. Now, when you factor a trinomials, you need to pay attention to the coefficient of x squared. If the coefficient of x squared is 1, because you need to pay attention to that, it all depends, right? To factor a trinomial of the form ax squared plus bx plus c, a little trial and error may be necessary. So we can do a trial and error if you want to, because in terms like this one, it's factored as, you need to have 2 terms like a plus b times a c plus d, right? There would always be 2 terms like this one, you see? That's how you factor trinomials. Well, so the first thing to do, assume for the moment that there is no greatest common factor, find 2 first terms whose product is ax squared. So that's the first thing. Well, you know what? The first thing to do, I'm gonna just go a little bit outside of what it says here, because remember, following the book is obviously not the best thing to do. But you know what? We're gonna do it different ways. We're gonna do it different ways. Let me insert a slide. I'm going to insert a slide and try. Okay, hold on, give me 1 second. Okay, when you factor, right? I'm gonna say factor. Okay, so we're gonna say factoring trinomials. Okay, factoring trinomials of the form ax squared plus bx plus c. If a is equal to 1, then then you have only x squared plus bx plus c. Okay, so if a is equal to 1, because you need to go with the conditions where a is equal to 1. If a is equal to 1, then you only have x squared plus bx plus c. To factor a trinomials of this format, to factor a trinomial of the form x squared plus bx plus c, okay, you said find 2 factors Okay, find two more numbers whose product is equal to C and sum is equal to B. Okay, now that's what you need to do. Then write it, okay, write it in the form like what you said, and you're gonna have like something x plus the first factor times x plus, I mean, I said plus and or minus the second factor. So those boxes represent the two numbers you'll find. For examples, if you have x squared plus 5x plus 6, now first of all, you know, because you only have x squared, then it's gonna be x for both. Now, two numbers, when you multiply, give you 6, okay? Two numbers, when you multiply, give you 6, but when you add, give you 5. What are these two numbers? Yes, that 2 and 3. So, 2 plus 3, right? 2 times 3 is 6, 2 plus 3 is 5, then that would be 2 plus x plus 2 and x plus 3. So that's how you're going to factor these trinomials. All right, so you got that examples correct, but you know what? How about if we have, that's A, if you have B, x squared minus 5x, okay? We're gonna say minus 5x minus 14. That's an example. So how are you gonna factor this one? What are the two numbers when you multiply give you negative 14, but when you add them give you negative 5? Two numbers when you multiply give you negative 14, when you add give you negative 5. Yeah, you got it. So you can multiply 2 times negative 7, that give you negative 14, and 2 minus 7, that give you negative 5. So we're gonna say x plus 2 and x minus 7. That's how you're going to factor these trinomials. We have a long list of trinomials we're gonna do. All right, so I believe we need to go also over a few examples. I'm going to copy and paste and just explain, okay? So how about if I remove that part, because let's try to remove that part, right? Okay. All right, we're gonna do, you know what? I need to remove everything. That's okay, that's fine. Let's do it. You know, if, okay, we said if A is not equal to 1, okay, if A is not equal to 1, that means not equal to 1, that means we really have ax squared plus bx plus c. In this case, doing a lot of trial and error would be fine, okay? It would be fine, okay? So that's very important. Otherwise, there are a variety of techniques we can use to do this one. The first thing we can do with an examples like this one is to make sure that, okay, first of all, we can use the AC method, okay? We use the AC method because remember, in that expressions here, you have A, B, C are constant. They are constant. They are real numbers, all right? They are constant, right? So all you need to do in this case, the AC methods, what it tells you to do, you multiply A with C. That means you have AC. Now, okay, two numbers. Two numbers when multiply give you AC, when add give B. Okay? Now rewrite B as a sum using these two numbers. To make the expressions. To make the trinomial a 4 terms. To make the polynomials a 4 terms. Then use grouping methods to factor the polynomial. So it's when the two, so one thing we need to make sure is when the two factors, because sometimes, as we said, the two factors can be very difficult to do, okay? So we can try to find two factors that would help us to do that. For examples, let's go, if I take I'm gonna write an example, examples. If we have 9x squared plus 5x minus 4, okay, you know what? I'm gonna take a different ones. Maybe it's in the next one, but let's take, I'm gonna say 9x squared minus 9x plus 2. You see, the coefficient of x squared is not 1. So it's a number greater, or it could be less also than 1. So the first thing I would do, make sure I do AC. Okay, so AC here, what is A? Remember, A is 9, B is negative 9, C is 2. So AC is 9 times 2. That gives me 18. Okay, so now give me two numbers, right? 9 times 2, 18. Now give me two numbers when I multiply, give me 18. Two numbers when I multiply, give me positive 18. Okay, but when I add these two numbers, it's giving negative 9. Yes, that's negative 3 and negative 6, right? Negative 3 plus negative 6 is like this. So you understand this part because I find these two numbers. Now, my next step is to rewrite the b term. So I keep my 9x squared. Now, instead of having negative 9x, I can rewrite negative 9x as negative 3x minus 6x. These terms right here still negative 9x plus 2, right? You see, there is these two terms in the middle. They equal negative 9x, our b terms. So what we do now, because it's 4 terms, we can use grouping. So we can group any two. You know, if you want to, we know we cannot, yeah, we can group any two. What I'm gonna do is group 9x squared minus 3x plus negative 6x plus 2. Now, let's do the 9x squared minus 3x. I think you already understand it. 3x would be our common factor. So we have 3x minus 1 left. And the second term, we can factor negative 2. So we have 3x minus 1. So 3x minus 1 is our common factor. And we have 3x minus 2 left. And that's an example of, you know, factoring a trinomial of the form ax squared plus bx plus c, where a is not equal to 1. Now, plenty of examples you can do. There are a lot of examples. The first one, two numbers when you multiply give you 40. When you add, give you 13. Two numbers when you multiply give you 40. When you add, give you 13. Let's go. I'm pretty sure you would remember. You know that. Can we do it? Yay! That's x plus 4 times x plus 9, because 4 times 9. Oh, no. Sorry. I lost in this one. It's 5 and 8. Yes. You're good. You're better than me then. This one is 5, 8. Okay? So you see, we have 5 times 8 is 40, and 5 plus 8 is 13. Okay? That's very giantly important. You know some other ones. Two numbers when you multiply give you 15. When you add, give you 8. Let's do it. Yes, that's 5 and 3. Right? 5 times 3, 15. 5 plus 3 is 8. Let's go over here. Two numbers when you multiply give you negative 5. When you add, give you negative 4. Yes, that's negative 5 times 1. So we're gonna have 1 times, I can say 1 times negative 5, give you negative 5. 1 minus 5 give you negative 4. Let's try it right there also. You can see two numbers when you multiply give you negative. Oh, I did that one with you already, right? So because I said two numbers when you multiply give you negative 14. When you add, give you negative 5 is negative 7 and 2. 2 times negative 7 is negative 14. 2 minus 7 is negative 5. Now, as you can see here, it's a little bit tricky because that one is totally different, because the coefficients are different. You know, when the trinomial has leading term that is not 1, the techniques we're using different. So we can first of all find two last terms whose product is the equal to negative 7. Okay, so we can try that and try combinations of all of them. So that's a trial and error. But because I want to skip trial and error with you, so using the grouping methods appear to be the best techniques, right? So what we're gonna do, first of all, you know, I'm gonna just take this one. You know what? I'm gonna copy, insert, blank. Now we do the factoring for this one, right? Let's factor this one. All right? Okay, let's factor it. We said in this case, so when you see this one, remember A is 6, B is 19, C is negative 7. So we can say, what is AC? equals 6 times negative 7, that's negative 42. Now, let's see that. Two numbers, when you multiply, give you negative 42. When you add, give you positive 19. Well, looking at this one, I would say that 2 times, negative 2 times 21, right? So negative 2 plus 21, right? So now I can rewrite the term in the middle. That is, I keep my 6x squared. I can say minus 2x, okay, plus 21x, that make it 19x, minus 7. Now, when I look at this one, I can group 6x squared minus 2x. I can also group 20x minus 7 because both of them has common factor. Looking at this, it gave me, I can factor 2x, so I have 3x minus 1 left, and I can factor 7, we have 3x minus 1. Remember, you must have the common factor in the grouping. The reason why you use grouping is because you're looking for a common factor. So 3x minus 1 is our common factor. 3x minus 1 times 2x plus 7. Remember, we can still do trial and error, but if you want to make sure that you get that 6x squared plus 19x minus 7, if you want to verify, you can use FOIL to check that. Okay, some expressions, if you look at this one, some expressions, for example, has more than that. For, let's say, if you see that, you know, you have this one, because we have two variables in this one. Let's go and insert a slide again for this one. Yeah, we're gonna continue insert slides, okay? Okay, let's try that one. Okay, this is what happened with these examples. Looking at these examples, the first thing I see myself is the fact that we have, you know, two variables, okay? So when you have two variables, it's make it a little bit different, okay? Because we can do all these examples using two variables. So first, find, we're going to focus on the 3x squared, okay? So if we look at the 3x squared, first of all, I'm gonna find what should I multiply together to obtain 3x squared. Two factors I multiply to find 2x squared. Find two terms whose product is 2x squared. Well, that's only 3x and x. That makes it 3x squared. Okay. Step 2, we need to find two last terms whose product is 4y squared. We're gonna try to find two of them that give you 4y squared. But the problem, we know 4y squared could be 2 times 2, 2y times 2y. We can try that one as well. But what we want to make sure, we need to look at the combinations. For example, if I put 2y here and 2y here, that's make it, because we see the terms in the middle right here is negative. Because it is negative, we know, because this one is negative, we know our sign in the middle must be negative. Now, let's see if you take this product plus that product, if it would give you negative 13. 3 times 2 is 6, negative 6 minus 2 give you negative 8. So we know that doesn't give you 13. So what we're gonna do is try a different number. So what are the other two products to obtain 4? Yeah, it's 4 times 1. I'm gonna change the color. Now, look, if we have negative 4, negative 3, that gives us negative 7. So that means that it's not 13 because we're looking for 13. All right, so that means the 4 is not in the correct place. So we need to switch again. Now the 4 would be here. Let's try again. Negative 12, negative 1. Is that give you a negative 13? Yes, we obtain the term in the middle. So that's how we need to factor when we have two different variables. First of all, find two terms whose product is 3x squared. Find two terms whose product is 4y squared. All right. Then try various combinations of these two factors. So the correct factorization, right, is the one in which the sum of the outside and the inside product is equal to the term in the middle, which is negative 13xy. Does that make sense? That makes sense? If you don't get it, please go slower. Use you can use try to use stop the video. That's what I wanted to say. Stop the video and try some other examples. When you look at this one, you have for this one, do you think that's something? Can you find two numbers when you multiply them? Give you 5. When you add, give you 2 in the middle. What I mean like that, not all the expressions can be factored. You can try many expressions, but not all of them can be factored. So if you look at here in H, you would say, oh, there is no common factor. There is no two numbers. When you multiply, give you 5. When you add, give you 2. Because 1 times 5 is 5. That's the only thing you can do, because 5 is a prime number, 2 is a prime number. So 1 times 5, the only way to obtain positive 5 is positive 1 times positive 5, but positive 1 plus 5 doesn't give you 2. Or you can do negative 1 times negative 5. Negative 1 plus negative 5 doesn't give you positive. So this is prime. Not all trinomials can be factored, so you really need to remember that. Let's move very quick in doing some other type of factoring that we call, I believe in this case, we can do so many other factorings. We're gonna factor the difference of two squares. A method for factoring the difference of two squares is obtained by reversing the spatial product for the sum and difference of two squares. So if A and B are real numbers, variables, or algebraic expressions, then you can say A squared minus B squared equal A plus B times A minus B. For example, if I have x squared minus 4, it's for me is I can write x squared minus 2 squared. If I can rewrite it as x squared minus 2 squared, then I can rewrite it x plus 2 times x minus 2. Remember, it doesn't matter which one you put first. Or if you want, you can say is x minus 2 times x plus 2. Either you do x plus 2 times x minus 2 or x minus 2 times x plus 2. It's commutative, 2 times 5, 5 times 2, both give you 10, right? Makes sense to you? Then it makes sense to me. Let's try this very quick. First of all, make sure you can rewrite 36x squared as this square, like this one. You need to make sure it can be written. So the difference of the square of two terms factors as the product of the sum and difference of these two terms. So we have 25 can be 5 power 2. Remember we said if you have A squared minus B squared, then it's A plus B times A minus B. That's the property. So we're gonna have 6x plus 5 times 6x minus 5. Over there, we already have x squared. All we need to do, can 9 is 81 a perfect square? Yes, it can be written 9 power 2. So it's x plus 9 and x minus 9. Remember, you could put the negative first with no problem, right? You could do that. It's no problem. We said also you could do 81. Yeah, this one is a little bit tricky, all right? This one is a little bit tricky. What happened? We have seen that a polynomial is factored completely when it is written as a product of prime polynomials, okay? To be sure that you have factored completely, you need to check to see whether any factors with more than one term in the factored polynomials can be factored further. If so, continue. For example, this one right here in C, we call this one a repeated factorization. I'm gonna show it to you. Look, when you factor that expressions, the first thing, we need power 2, right? So what we're gonna do, we do 9x squared power 2 give you 81 power 4, because power of a power, don't forget, a power m power n is a power m times n. Is for power of power. Now, you know for 16, it's gonna be 4 power 2, right? Okay, using our first factoring the difference of two squares, we're gonna have 9x squared plus 4 times 9x squared minus 4. Now, looking at these two terms, we see something strange. 9x squared plus 4, these terms is really prime. So you cannot factor when you have, that means we said a squared plus b squared is prime, right? Cannot be factored. So the first term is okay. But look at the second one. We can rewrite the second one as, we're gonna keep the first one as is, 9x squared plus 4 times 3x power 2 minus 2 power 2. So that means 9x squared plus 4. Now we're gonna redo that again. 3x squared minus 2x squared gives us 3x plus 2 times 3x minus 2. It's extremely important that we factor completely, right? Because they shouldn't have any common factors. So each expression must be prime. Like 9x squared plus 4, no common factor. 3x plus 2, no common factor. 3x minus 2, no common factor, right? So we consider them all being prime. So that's factoring the difference of two squares. How about we factor perfect square trinomials? Well, it's the reverse of s plus b we did in the previous section square. We said take this first one power 2 plus 2 times the first one by the second one plus the second one power 2. Or if you have the negative sign in the middle, you can do a square minus 2ab plus b square. So you can reverse it, because that technique is reversed the special products for squaring binomials. The trinomials that are factored using these techniques are called perfect square trinomials. If you let a and b be real numbers, remember those are real numbers, variables or algebraic expressions, if you see something like this one, you can rewrite it like that. But make sure when you take 2 times this one with this one, it gives you the whole thing in the middle. So that's what you need to pay attention to. And when it's negative, the only thing that make it different is the sign in the middle. Now, first of all, when I look at this term, I want to make sure I can rewrite the first one as a square. So I'm gonna put what I raise to power 2 to obtain this. What do I raise to power 2 to obtain this? Yes, that's for x. What do I raise to power 2 to obtain this? Yes, 7. Now let's try. If I multiply these two by 2, so if I do 2 times 4x times 7, if it give me the term in the middle, then I would factor it 4x minus 7 power 2. But I need to verify first. If 2 times 4x times 7 give me 56, I see 2 times 8, 2 times 4 is 8, 8 times 7 is 56. Yes, so that's correct. Okay. If we look at the second one, what we raise to power 2 to obtain x squared is x. What we raise to power 2 to obtain 49 is 7. Now look at if you do 2 times x times 7, does that give you 14x? Yes, that gives you 14x with a plus sign. So it's gonna be x plus 7 power 2. You know, I could try a variety of examples, but you're gonna have time because remember you have a nice, beautiful book that you can try so many examples. But in the meantime, let's just cover a few of those factoring techniques, because factoring the sum or difference of two cubes is also something very special, right? So pay attention on how we're gonna do that. For example, if I have a cube plus 8, remember 8 can be written a cube plus 2 cube. So that means it tells me to do x plus 2. That means a plus b. X squared, that's the first term. Now minus, there is a minus in the one with the sum, but in the second parenthesis, ab, that means x to 2x. Plus b squared, that's 2 squared is 4. It's the same. If I have x cubed minus 27, it's the same thing saying x cubed minus 3 cubed. So that means we can do x minus 3 times x squared plus 3x plus 3 squared, that's 9. You know, those are a few examples you can do. I'm hoping I don't take the same one. Sometimes it doesn't show you exactly its power 3, but you know what you raise to power 3 to obtain 125 is 5, right? 5 times 5, 25 times 5, 125. So 5x cubed give you 125x cubed. You know, minus what you raise to power 3 to obtain 8 is 2. Now, as the technique says, if you have negative in the middle, you keep the negative in the first parenthesis, but no negative in the second one. Now, a squared, 5x squared is 25x squared, plus ab, that means 5x times 2 give you 10x, plus b squared, 2 squared give you 4. That makes sense? If it makes sense to you, then it makes sense to me. So, but we can continue and try some other examples. Look at this one where we said, oh, you know what? How about we rewrite this one as x cubed plus 1 cube? Yes, you didn't see that one coming because 1 power any number is equal to 1. So 1 cube, that means x plus 1. Now x squared plus x times 1 is, no, that would be a negative. Remember we said there's a negative. That means 1x plus 1 squared is 1. And that's it. That's it. We have so many examples. Should we stop here or should we continue? No, we're gonna see only two more is a strategy for factoring polynomials, right? It is important to practice factoring a wide variety of polynomials so that you can quickly select the appropriate techniques. So the polynomial is factored completely when all its polynomial factors, except possibly for monomial factors, are prime, okay? So you need to make sure each factors are prime. Because of the commutative properties, the order of factors does not matter. So either you do 2 times 5, 5 times 2, no problem. All right. So a strategy for factoring a polynomial, if there is a common factor, factor out the GCF. Okay? Identify the greatest common factor and factor it out. Determine the number of terms in the polynomial and try factoring. If there are two terms, can the binomial be factored by using one of the following special forms? So the difference of two squares, we covered that. Sum of two cubes, we covered that. Difference of two cubes, we covered that. You see, you can use those to factor. Factor, there is always a parenthesis when you factor, all right? If there are three terms, is the trinomial the perfect trinomial? You can ask yourself that question. If so, factor by using one of these we covered. So ax squared plus 2ab plus b squared, you can just do a plus b, power 2, or you can do that. If the trinomial is not perfect square, try factoring by trial and error. Maybe it's one of them. If there are four or more terms, try factoring by grouping and check to see if any factors with more than one term in the factored polynomials can be factored further. So if so, factored completely. You need to do that, okay? We want to try one or two more examples. For example, here, if we give you 3x cubed minus 30x squared plus 75x, the first thing I look at here is to make sure I don't have any GCF. Oh yeah, I do. There is a 3, there is a 30, in 30 there is a 3, there is a 75, in 75 there is a 3. So meaning I can factor 3 out. I see there is an x in each of them. There is an x here, there is an x here, there is an x here. Always factor out the GCF. So if I factor 3x, what do I have left from the first one? Yes, x squared. If I factor 3x from negative 30x squared, I have left negative 10x. Yes. 75? Yes, 25. Now you see, you must factor completely. Factor completely. Now, when I look at this one, I realize that two numbers, because the coefficient of x squared is 1, I would try to find two numbers when I multiply, give me 25. When I add, give me negative 10. Two numbers multiply, give you negative 25. When you, positive 25. When you add, give you negative 10. Yes, it's negative 5 and 5, negative 5. So you can factor x negative 5, x minus 5 times x minus 5. This is one of the techniques. But because both of them is like a times a give you what? A square. So we can do 3x times x minus 5 power 2. Or you can look at this one as the trinomials of a perfect square, because you can 2 times 5, give you 2 times negative 5, give you 10, right? Now, in the second examples you see here, in the second one, well, the problem, there is a, we have a lot of things, okay? So having something like this one, my first question is if there is a common factor, okay? We need to factor out the GCF other than 1 or negative 1. I'm looking, there is no common factor. Now, the second technique is determine the number of terms and factor accordingly. So as you can see here, we have 4 terms. So we need to try to factor by grouping, okay? We're gonna try to factor by grouping. First of all, you can try any of these. Okay, this is what I'm gonna do. I see I can put x squared plus 20x plus 100 minus 36a squared. That's a technique. Because when I look at the first one, look at what happened. I can two numbers when I multiply give me 100, or I can use because this one is x squared, this one is 10 squared. So 2 times the first one by the second, 2 times x times 10 give you 20. So meaning I can rewrite this one as x plus 20 power 2 minus 36 a squared. I can rewrite it like this, right? Or if you want two numbers you multiply by 100, when you add, give you 20, it's 10 times 10. So x plus 10 times x plus 10 give you x plus 10 power 2. Now we go back to something we know for us is like a squared minus b squared. A squared minus b squared give you a plus b times a minus b. What I mean by that, I can rewrite this one as x plus 10 power 2 minus 6a power 2 give me 36. So that means I can do x plus 10 plus 6a times x plus 10 minus 6a. And that would be my beautiful final answer. I believe I do one examples of each to really help you to complete. But one more thing is how we're gonna factor algebraic expressions, because one thing we can see, although expressions containing fractional and negative exponents are not polynomials, they can be simplified using factoring techniques as well, right? So that's what we're showing in these little examples. We said that because the greatest common factor here, is we see that there is an x minus 1, okay? With the smaller exponents, we're gonna use it with the smaller exponents. So meaning, for us, I can see if I do x minus 1 power what? I need to take one of these exponents. So if I do power 1/2, I have x left for the first one plus x minus 1. Because power 1, look, if I have x minus 1 times x power minus 1 power negative 1/2, what happened? Because there is a power 1 here, right? So if I add the exponent, because remember a power m times a power n, you add the exponents, right? So meaning you can do x minus 1 power 1 minus 1/2. So that would be x minus 1 power positive 1/2, because you're gonna put same denominator. 2 minus 1 is 1. Okay, now that's why when I factor here, the second parenthesis, I use only x minus 1. So you'll see what happened. I can do, I have x minus 1 power negative 1/2. That's 2x minus 1. Okay, so having 2x minus 1, we can leave it like this one, or I'm gonna erase. Or what I do is, because power negative, we don't like power negative. We said if you have a power negative n, you can do a power n. So for me, I can rewrite this one as 2x minus 1 over x power negative 1 power 1/2. And you know power 1/2 what's represent is square roots. You can do it square root also. Square roots of x minus 1. So either of these two works. Okay, that's factoring polynomials. I'm hoping you enjoyed that. We're gonna come back in a different video to talk about rational expressions. In the meantime, take care and do not hesitate to let me know if you have any questions. I'll see you soon in a different video.